You close your eyes, the world dims. The sounds around you fall into hush. Somewhere far above, stars shimmer, not as points of fire, but as the quiet memory of a very old beginning. You drift, weightless, into thought. In this stillness, a deeper quiet calls. Imagine the universe, not as a place, but as a breath, slow and wide, barely perceptible. In the beginning, it wasn't filled with stars or galaxies. There was no night sky. There was no sky at all. There was only space, wrapped in stillness, waiting to stretch. But space does something surprising. It expands, not like a balloon. Filling with air, not quite. That image is close, but still too loud. Picture instead a sheet of silk, cool and weightless, spreading in every direction all at once. The silk is space itself, and with it everything that ever was or ever will be begins to unfold. This expansion isn't violent. It isn't explosive. It's more like a sigh, long, invisible, and unstoppable. In the very first moments, after the universe was born, there was a brief, strange period we now call inflation. It lasted for just the tiniest flicker of time, so brief you couldn't blink fast enough to match it. But during that tiny breath of a moment, space grew unimaginably vast. From smaller than a single atom, the cosmos swelled outward, smooth, uniform, and astonishingly fast. You might wonder, what caused that first breath? What made space expand? The truth is, we don't know for certain, but something stirred in the emptiness. It's not a thing exactly, but a condition. A kind of tension held inside the vacuum itself. And when that tension released, it didn't explode, it unfolded. The universe wasn't pushed out from some center. Instead, every part of it expanded away from every other part, like dots. On the surface of an inflating sphere, each drifting silently apart. In this newborn universe, there was no sound. There was no light, not yet. Just the hum of quantum fields vibrating with potential. Just enough energy to seed the future. And in this strange silence, the fabric of reality stretched. If you could float through that early space, there would be no up or down, no shape to hold. Just smoothness, like an untouched lake, spreading in all directions. But hidden in that calm were ripples, small, random fluctuations, barely their differences in density and energy. These would become everything, stars, planets, even you. Space didn't stretch into emptiness. It created space as it expanded. There was no outside to grow into. The expansion was space itself, making room, moment by moment, for time and light to begin. Think of it like this. You are lying on your back in a vast field at dusk. The air is perfectly still. You exhale slowly, softly. The air around you responds, not with motion, but with space. A sense of widening, as if your breath made the world slightly larger. That is how the universe began to breathe. Even now, this expansion continues. Quietly, relentlessly. Every second, space adds more space between the galaxies. You don't feel it. The atoms in your body remain bound. The Earth stays loyal to the sun. But between distant galaxies, between clusters of clusters, space stretches. The breath continues. And it's not slowing down. In fact, it's speeding up. But that comes later. For now, let your thoughts rest in this early rhythm. Before stars, before atoms, before time as we know it. Just you and the stretching silence. Just you and the breath of space. There's comfort in knowing that even the most enormous things, galaxies, universes, begin with stillness. With tiny motions, with a gentle release of tension. In that moment, the universe was not loud. It was soft, mysterious, alive with invisible purpose. And even now, when you close your eyes, you can feel it. A faint widening, a drifting sensation. The sense that everything is still moving, still unfolding, still breathing. And just as you settle into that quiet breath, question rises with the night air. If the universe is always expanding, why does it never stop? Which brings you gently to the next chapter, a universe that won't sit still. You open your eyes, but not to the world around you. Instead, you gaze inward, outward, upward all at once. You're floating again, high above a world wrapped in quiet sleep. Above you, galaxies drift like lanterns down an invisible stream. They aren't anchored, they aren't still. They move away, all of them. There's no sound to their motion, no wind, no wake. But something strange is happening, something you can't quite feel, but you can see. In the early 20th century, astronomers began to notice a curious shift in the light from distant galaxies. It was subtle, like a whisper stretched too thin. They passed starlight through a prism. They expected certain colors, fingerprints of the elements within. But the lines weren't where they should be. They had shifted toward red. This wasn't an accident. It was the sky's quiet way of saying, I am moving away. It's called redshift, the stretching of light as the source moves farther from you, like the deepening pitch of a train whistle as it pulls away. Light, too, can stretch, and in space, it does. They're surrounded by galaxies, all receding. The farther away they are, the faster they seem to run. Not from any explosion, not because of a force pushing them through space, but because space itself is expanding gently, pulling them apart. Imagine you're lying on a large sheet of soft fabric. Around you, small toys sit scattered, each representing a galaxy. Now, someone begins to stretch the sheet in every direction, slowly, smoothly. As the sheet widens, the toys glide apart. Not because they are moving themselves, but because the space beneath them is growing. That is what Edwin Hubble helped. USC. In 1929. He measured the speeds and distances of galaxies and found a pattern. The farther a galaxy is, the faster it appears to move away. It was as if the entire universe were swelling, like bread rising quietly in the oven of time. But this isn't motion like you know it. You are not watching galaxies rush through space. You're watching space carry galaxies with it. Like leaves on a river, they drift not by their own will, but by the current beneath them. This realization changes something deep within you. It means there is no true center of the universe, no privileged position, no anchor point. Wherever you stand, it looks like everything else is receding, and that's because it is. You might feel small knowing this, but there's also something peaceful in that smallness, a kind of belonging to a rhythm too vast to disturb. You are not just in the universe, you are of it, carried in its quiet swell. The galaxies are not racing. They are being cradled, outward, like petals drifting apart on the surface of a slowly spreading pond. Still, you wonder, if galaxies are moving away now, were they once closer? Yes, much closer. So close, in fact, that they were once one. Rewind the expansion, and you arrive at a single point, a moment beyond time, where the universe began. A beginning not with fireworks, but with unfolding. But now we know this expansion continues, and it is not slowing. It is accelerating. That whisper grows louder, though it remains silent. That motion intensifies, though it remains unseen. Something is urging the universe apart faster and faster. It's not because of the momentum of the past, but because of a presence we cannot see, something beyond gravity's grip, something soft and invisible, but strong. You feel it even now in your thoughts. The sense that things are always shifting, that stillness is an illusion. Even in rest, the universe flows. And so, under a sky that won't hold still, you rest your mind in motion. You let the stars drift from your view like fireflies on a breeze. You close your eyes again, just as the question forms. If everything is moving, farther and faster, what force is pushing it all apart? And so begins your journey into the invisible wind. What is dark energy? You feel it now, gently, in the weight of your limbs. Gravity, soft and sure, holds you close to the earth. It wraps around you without asking, like a familiar blanket. You don't need to think about it. It simply is. It has always been. There, cradling your body, tethering your every step. Gravity not through numbers, but through sensation. When you drop a pebble, when you lie down, when you fall into sleep, it is the most trusted of forces, patient, invisible, unbreaking. And yet out beyond the warmth of your world, gravity is not alone. In the vast reaches between galaxies, something resists it. Something that doesn't pull in, but pushes out. First, let's stay with gravity a little longer. Imagine it not as a force, but as a shape, a curve. Every object from the moon to your body presses gently into space, and space responds by curving around it. It's like laying a ball on a soft mattress. The ball makes a dip, and anything that rolls nearby will spiral toward it. This is what Einstein taught us. Gravity isn't a pull from a distance. It's the bending of space and time around mass. Stars curve the cosmos. Planets ride the curves. Even light bends when it passes too close. And for billions of years, gravity was the great sculptor. It gathered dust into stars, stars into galaxies, galaxies into clusters. It pulled everything inward, ever so patiently, trying to hold the universe together. But now gravity is fading. Not because it's weakened, but because something stronger is working against it. You float now between galaxies. You watch them dance apart, not tumbling, not flying, not resisting, simply moving with the breath of space, and faster than they should. If gravity were in charge, this expansion should slow down. Like a ball, thrown upward, it should hesitate, pause, and begin to fall. But it doesn't. The galaxies don't slow. They speed up. The space between them grows wider and wider still. It's as if some silent pressure lies within the fabric of the cosmos, pushing outward, everywhere, all at once. Call it dark energy. Not because it's dark like night, but because it's hidden, unknown, not yet understood. Strange. Energy doesn't act like anything we know. It doesn't clump. It doesn't gather. It spreads evenly through space, as if it were part of space itself. And as the universe grows, so does dark energy. More space means more of it. Now imagine. Again, that soft mattress of space-time. But this time, instead of placing balls that make dents, someone is gently stretching the fabric beneath you. No matter how many curves gravity creates, this stretching flattens them, thins them, pulls them apart. Galaxies become islands, isolated by the sea of expanding space, each too far from the others for gravity to reach across. It's not just that gravity is fading, it's being outpaced. Even the strongest bonds, like those between galaxy clusters, will one day stretch until the connection breaks. You rest your thoughts on this cosmic tug-of-war? On one side, gravity pulls everything inward, patient and precise. On the other, dark energy whispers outward, steady, quiet, relentless. In the early universe, gravity had the upper hand. It shaped everything we see. It brought light from chaos. But now, dark energy is winning. And the more it wins, the harder it becomes to stop. This doesn't bring destruction, not yet. It brings solitude. Galaxies drift until their neighbors vanish from view. Light itself stretches into invisibility. And the night sky becomes darker, not from the absence of stars, but from the growing silence between them. You breathe in deeply and feel gravity still holding you. You are here, warm and safe, because gravity has not let go. But out there in the far-off reaches of the cosmos, something is rewriting the rules. And you wonder, what is this strange? Invisible energy that dissolves the universe's embrace? What is it made of? Where did it come from? You settle into that question, feeling the pause between understanding and wonder. Because to know what dark energy truly is, you must first step into the mystery itself. And so you drift toward the next chapter, the invisible wind. What is dark energy? There are forces you can touch. The warmth of sunlight on your skin, the pull of earth beneath your feet, the whisper of wind against your face. These are familiar. They speak in sensations, in movement, in weight. But now you float into a part of the universe that never speaks aloud. Here the silence is complete, and yet something is moving everything. You've already felt its trace in the way galaxies drift faster the farther they are. In the fading grip of gravity that can no longer hold everything close, there is something at work that we do not see, but that moves the very scaffolding of the cosmos. This is dark energy. The name itself is a placeholder, not a truth but a question. It does not glow. It casts no shadow. It offers no texture. And yet, it fills more of the universe than stars, planets, dust, or even dark matter. Almost 70% of everything is this invisible wind, and yet no one knows exactly what it is. You drift deeper into thought. Let go of the need to define, and listen instead. Dark energy is not a force like magnetism or gravity. It doesn't pull. It doesn't push in the usual sense. It is more like a pressure built into space itself, a quiet, persistent hum that grows stronger as space expands. Imagine space as the surface of a calm lake. Now picture tiny ripples forming not from the wind above, but from something deep inside the water, a hidden vibration that stirs everything upward and outward. That is how dark energy behaves. It stirs space from within. Where does it come from? One idea whispers from the quantum world. In quantum mechanics, even empty space is not truly empty. It seethes with energy, flickering with particles that appear and vanish like fireflies. This is called vacuum energy, a sea of invisible fluctuation. Could this restless energy be what pushes the universe apart? Could empty space by its very nature contain the power to grow? It's possible, but the numbers don't quite match. The energy predicted by quantum theory is far too large, so immense that the universe would have torn itself apart in an instant. And yet, here we are. So either something is wrong with our equations, or something deeper, something quieter, is guiding the expansion. Another possibility lies in the shape of space itself. Einstein once added a term to his equations called the cosmological constant. He used it to describe a universe that doesn't collapse or fly apart, one that balances. He later called it a mistake. But now we wonder, was it? Perhaps the universe does have a built-in natural tendency to expand. Perhaps space itself carries a faint, constant urge to grow. You let this idea settle like dew on a leaf, silent property of existence to unfold, to widen, to make room. There are other theories too, floating gently at the edge of knowledge. Some suggest that dark energy changes over time, like weather in the vacuum, waxing and waning as the universe ages. Others imagine unknown fields, new kinds of energy, or even that our understanding of gravity itself needs to change when space grows too large. Each idea is delicate, a shimmer in the dark. None have yet found the answer, but all agree on this. Something is there. Something moves everything farther apart, even now, in this moment, as you lie still. Now, billions of light years away, galaxies continue their slow retreat. They do not know why. They simply respond to the invisible wind that moves through everything. You feel it, in a way, not as a breeze, not as motion, but as the knowledge that nothing is ever truly still, that rest itself is a part of movement, that the calmness you feel now is not the absence of force, but its perfect balance. You float with this thought, wide and silent. Science may not yet grasp what dark energy is, but it has seen what it does. It shapes the fate of the universe, decides whether the stars will drift forever or come home one day, and it hides, not in some distant place, but in every inch of space around you. You breathe slowly, as if trying to match its rhythm, a presence that is nowhere, and yet everywhere. And as you drift toward sleep, you sense it, a force not of pulling, but of letting go, a universe that expands, 'cause it must. But even this invisible wind had to be discovered. And to understand its place in the cosmic puzzle, you must look back to a quiet idea in Einstein's mind. Once discarded, now returned. And so you begin to sense the shape of the next chapter. Einstein's quiet reversal. There are moments when even the greatest minds doubt their own thoughts. You feel it sometimes, that quiet second guess, a hesitation at the edge of understanding. Now imagine such a moment, but in the stillness of a room where the shape of the universe is being written. It was the early 20th century. Albert Einstein sat with equations scattered like stardust across his desk. He had just reshaped how we see gravity, not as a force, but as the bending of space and time by mass and energy, elegant, profound, but something troubled him at the time. Most scientists believed the universe was static, unmoving, eternal, and Einstein's equations, left untouched, predicted the opposite, a universe in motion, either expanding or collapsing. So he reached into the heart of his theory and added something new, a small term, soft and strange, the cosmological constant. It was a quiet adjustment, like a hand placed gently on the shoulder of the cosmos, meant to balance gravity and hold the universe still. This constant, known as lambda, didn't push or pull in the usual sense. It was more like a tension within space itself, a kind of quiet pressure. With it, Einstein hoped to preserve the universe as it was thought to be, unchanging, but the universe had other plans. Years later, when Hubble would look into the sky and see galaxies drifting apart, the unmistakable sign of cosmic expansion. Einstein, hearing this, is said to have called the cosmological constant his greatest blunder, not because it was wrong, but because he used it to force stillness where motion was true. And yet, time has a way of turning doubts into discoveries. As the 20th century came to a close, astronomers stared deep into the night, into the flicker of dying stars known as Type Ia supernova. These were cosmic lighthouses, so consistent in their brightness that they could be used to measure vast distances. What they found surprised everyone. The universe wasn't just expanding, it was accelerating. Galaxies weren't slowing as they moved apart. They were speeding up, as if pushed by an unseen hand. That unseen hand, it seemed, might be lambda after all. The cosmological constant, once discarded, returned like a forgotten melody, suddenly meaningful. It offered a simple way to explain the growing space between galaxies, not a force in the usual sense, but a quiet property of space, present even in perfect emptiness. You pause here, letting this thought settle like dust in moonlight. Sometimes we don't yet know the purpose of what we create. Sometimes, understanding comes only after the silence has deepened. Einstein's quiet reversal reminds us of something gentle, but profound, that science is not always a march forward. It is a circle, a rhythm, a slow unfolding of ideas that rise, fall, and rise again. Even now, the cosmological constant may not be the final answer. It fits the observations, but we still don't know what it is. Is it a true feature of spacetime, a shadow of quantum energy, or a placeholder for something deeper still? You don't need to solve the mystery tonight. You only need to feel the shape of the question, like running your fingers along the grain of unfinished wood. The universe is not static. It never was. And the constant once meant to freeze it in place may now be the key to understanding why it moves. And yet what kind of space are we expanding into? Where does all this motion go? Perhaps the shape of the universe itself holds an answer, and so you drift gently into the next chapter, a universe with no edges. You close your eyes and picture it, a distant wall, an end of space, a place beyond which there is nothing, a final star, a last planet. Then silence, blackness, an edge. It's a natural thought, comforting even to believe the universe has limits. It's like a room with walls, like the skin of a bubble. But the truth is softer and stranger. Space does not end. It does not sit in something larger. Space is the thing, stretches and bends and folds, not into anything but within itself. There is no edge. There is no outside. And yet, it continues to grow. You are now drifting through this idea, weightless, like a speck of dust in sunlight, carried through space by a current you cannot see. What does it mean for a universe to expand, but have no boundary? To grow, yet never reach? The answer begins with shape space. Like paper or fabric, can bend. But unlike the flat sheets you're used to, space doesn't need to bend into something. It curves internally, in dimensions your senses don't feel, but your imagination can just barely graze. Imagine standing on the surface of a balloon. Walk in a straight line long enough, and you'll loop around. There's no edge, only smooth, continuous surface. From any point, the world seems endless. Now imagine that, but in 3 dimensions. This is the kind of curvature our universe may have. Not a balloon floating in a larger room, but space curving within itself. Not just outward, but through every point. Equally, astronomers try to measure this curvature. Peering into the oldest light in the cosmos, the cosmic microwave background. They look for hints. Are parallel lines staying parallel? Are large triangles shaped as they would be on a flat surface? So far, the universe appears remarkably flat, not curved like a sphere nor like a saddle, flat but vast. So vast, in fact, that even if it curves slightly, the curve would be too gentle to see from where we are. Yet even flat space can expand. And it does, not pushing into emptiness, but creating more space between points that already exist. Picture a grid of dots drawn on a rubber sheet. Stretch the sheet and the dots move farther apart, but the sheet itself remains the same. Type of surface. No edge appears. No hole forms. Just more distance, more between. This is how galaxies move away, not through space, but with it. The stage itself is growing. There's no backdrop, only the fabric of the play. And so, your mind gently releases the need for boundaries. It makes peace with endlessness. Infinity not as a number, but as a direction without stop. This doesn't mean the universe is infinite in size. It might be, it might not. But from your point of view, you could travel forever and never find a wall. If you flew in one direction long enough, you might end up back where you started, not because you reached an edge and bounced, but because you wrapped around a space that loops in upon itself. Some models of the universe allow for this, a cosmic hall of mirrors where light folds and returns, where distant galaxies may even be echoes of our own. But no matter the shape, flat, curved, looped, one truth remains. Space doesn't expand into anything. It is space itself that stretches, like breath in a chest, like thought opening wider than words can hold. This expansion is not something you feel directly. Atoms remain bound, stars stay steady, gravity holds local hands. But between the largest things, space continues to soften and widen. And in this soft widening, the universe grows colder. Stretched light becomes invisible. Lonely galaxies drift too far to be seen. The night grows darker, but it's not an emptiness to fear. It's a kind of quiet richness, a universe growing not to escape something, but simply because it must. There is no center, there is no edge, there's only between. And so you drift through that idea, floating between stars that grow farther, not from force, but from the unfolding nature of being. You are not outside this process. You are within it. Your body is stitched into the shape of space, and your thoughts ride its gentle curves. There is no boundary to contain you, only the quiet invitation to wonder. And now, as you rest into this truth that space has no end, only flow, another thought arrives. If space expands so gently, so smoothly, what ripples in its stillness gave birth to the stars? And so you begin to listen for the next chapter, the silent architects, quantum fluctuations. You've heard silence before, in a dark room, in a breath held, in the hush just before rain touches the earth. But there is a deeper silence, one that exists in places no sound can reach. The silence of empty space, not the emptiness between trees or buildings, but the kind found between galaxies, where even starlight grows thin. You might think there is nothing there. No air, no dust, no warmth. Just a perfect, motionless void. But space, you see, is never truly empty. Beneath the stillness, there is movement. Tiny, flickering pulses. Unseen waves rising and falling. In a sea of possibility, this is the world of quantum fluctuations, the restless hum of the universe at its smallest scales. Here, particles do not exist like marbles or pebbles. They appear, vanish, and reappear like whispers in a dream. Pairs of particles and their opposites wink into existence, borrow energy for the briefest of moments, then disappear again. Before they are noticed, they are not mistakes. They're features woven into the very nature of reality. In quantum mechanics, every field, for every force, every particle is alive with energy. Even in its lowest state, a field trembles softly. It's from those tiny tremors entire galaxies may one day be born. You are floating now through that early universe, just after the moment of inflation. Space is stretching faster than light can travel. It is smooth, vast, unimaginably empty. But not perfectly smooth, not perfectly empty. Those flickering quantum fluctuations, random, small, barely there, are being stretched too. They begin as ripples, but inflation pulls them. Like threads across the sky, magnifying them to cosmic proportions. These ripples are not erased. They are frozen in the fabric of space, and over time they become the seeds of everything. The places where the ripple is a little higher, where the field held slightly more energy, will eventually gather matter. And where it dips slightly lower, space will remain quiet, bare, unfilled. Out of this gentle randomness, galaxies will form. Stars will burn, planets will spin. You will dream. Imagine tossing flour across a surface of still water. Some spots will land heavier, some lighter. Where the flour collects, something new can grow. The entire structure of the cosmos, every cluster, every filament, every corner of light and dark traces back to these trembling, early imperfections. And so, from almost nothing, something begins.
Oh.
This does not break any law. It is the law. The quantum world doesn't behave like the world you know. It is not neat, not steady. But it is consistent, and in its chaos, it builds. You might wonder how such randomness leads to such beauty. How can scattered tremors lead to stars arranged like lace? But that's the mystery. The tremors are not aimless. They're guided by the rules of physics, equations that know no language but obey a perfect rhythm. Even now, the patterns they created are visible in the cosmic microwave background, the afterglow of the Big Bang. Stretched thin across the entire sky, it's like looking at a baby picture of the universe. A soft, dappled glow, tiny warm and cool spots. Those spots are the fingerprints of the silent architects, the echoes of quantum ripples, written in light. You breathe in, slowly, and you realize that the same laws that built the stars also shaped the particles in your body. The atoms in your hand were once part of those early fields, responding to those same fluctuations, rising from the same sea of uncertainty. You are not made of stardust alone. You are made of pattern, of probability, of paused motion stretched across time. From the outside, it seems miraculous. But from within, it is simply how the universe works. A quiet order hidden within disorder, a stillness that dances just beneath the surface. And so you lie here, perfectly still, while the memory of movement continues beneath you. Not all creation begins with noise. Not all beginnings are loud. Sometimes the entire universe can begin with a whisper. You float in that whisper now, trusting it to hold you, to guide you toward something even deeper. Because though we now know the origin of pattern, how do we detect something we cannot see? How do we measure a force that hides within the silence? And so your journey drifts gently onward. Into the next chapter, measuring the unimistra. How do you find something you cannot touch? How do you measure what leaves no shadow, no sound, no weight in the palm? These are the questions whispered. In observatories and labs where the lights are dim and the instruments listen instead of look, because dark energy, like dark matter, does not shine. It does not reflect. It does not fall into your hands. And yet, it moves the stars. It stretches space, leaves behind signs. If only we're still enough to see them. Imagine standing at the edge of a frozen lake at night. The surface looks perfectly smooth, still, but if you listen closely, you might hear a distant crackle, ice shifting somewhere far across the blackness. You didn't see the motion, you didn't feel it. But the pattern told you something changed. That is how we detect the undetectable. Not by grasping it, but by watching what it does. We begin with light, the universe's messenger, ancient and tireless. Light from distant galaxies travels for billions of years, crossing a growing universe. To reach us, But something happens along the way. Its wavelength stretches. This is redshift, and it's more than just a color change. It is the fingerprint of expanding space. By studying thousands of galaxies and measuring just how much their light has stretched, astronomers can map how quickly space is growing. And when they compared galaxies near and far, they found something remarkable. The expansion is speeding up. This was the first whisper of dark energy. Then came the supernova specifically, type I a supernova. Brilliant explosions so consistent in brightness that they can be used as cosmic mile dash markers. By observing how dim these explosions appear, we can tell how far away they are. And by measuring their redshift, we know how fast they're moving. In the 1990s, teams of astronomers compared dozens of supernovae and discovered that distant ones were fainter than expected, not because they were small, because they were farther away than they should be. The universe had expanded more than predicted. Something was pushing everything apart and pushing faster than gravity alone would allow. This was no mistake. It was a signal, a clue, like a barely visible ripple in a still pond. Then there is the cosmic microwave background, the oldest light we can see, released when the universe was just 380,000 years old. This light carries within it tiny variations in temperature. Warm and cool spots mapped across the sky. These variations trace the early structure of the cosmos, tiny seeds of galaxies planted by quantum fluctuations. But more than that, it's the way these fluctuations are shaped and spaced reveals the geometry of the universe. If the universe were closed like a sphere, or open like a saddle, these patterns would bend, stretch, cluster differently. What we observe suggests something else, a universe that is flat, but filled with more energy than we can account for. Dark energy, again, is the missing piece. Not just a guess, a necessity. The numbers are to make sense. Other clues arrive in the rhythm of galactic clustering, the way galaxies group and spread over time. Even in the patterns of galaxy surveys, in the way light is bent by gravity. Through gravitational lensing, we find traces of a gentle, invisible pressure expanding the cosmos. It's like walking through a forest at night. You cannot see the wind, but you see the leaves rustle, the trees sway, the branches lift. Dark energy is the wind. The universe is the forest, and we, careful and quiet, trace the motion with our instruments, with our minds, with the slow, faithful work of wonder. Still, we do not know what dark energy is. Our tools measure how much and what effect, but not why. Is it constant? Does it change over time? Is it a property of space itself or something new, waiting to be discovered? Even as we gather data, the answers remain elusive, but the search brings its own kind of peace. To measure the unmeasurable is to believe the universe will speak softly, subtly, to those who know how to listen. And you are listening now. Not with ears, but with attention. You rest within this mystery, knowing that questions, too, can be beautiful. Because even when you cannot hold the truth, you can hold its shadow. And even a shadow, when traced carefully, can reveal the shape of something vast. Still, we ask, if dark energy fills space and grows as space expands, what happens in the far future when galaxies have drifted beyond sight? What kind of end does a universe like that dream of? And so you drift onward into the next chapter, the quiet future, a universe grown cold. Close your eyes and let time melt. Not seconds or hours or even years, but eons, centuries, layered upon centuries, until the present slips from your hands like water through open fingers. Now open your mind to the quiet future, not tomorrow, not next year, but a future drawn out across billions, trillions of years. What does the universe become when the stars begin to sleep? You are drifting forward through deep time. Galaxies still spin, stars still burn, and planets still turn beneath distant suns. But slowly, gently, change begins. Dark energy continues its silent work. Space stretches. Galaxies drift farther, then farther still. Each one becomes more isolated, like a ship disappearing beyond the curve of the sea. Eventually, from any one point in space, most galaxies will vanish from view. Not because they are gone, but because their light can no longer reach us. The universe has grown too wide. Even light, traveling at its limitless speed, cannot keep up with expansion. The stars closest to us, those in our own galaxy, will remain for a time. They burn, flicker, and die, as they always have. But fuel runs low. New stars form less often. And the old ones, even the mighty blue giants, end in silence, as white dwarfs, neutron stars, or quiet black holes. Darkness slowly becomes the rule. The night sky, once full of light, shrinks to a scatter of lonely suns. And then, colder. Still stars fade, cooling into embers over trillions of years. Even the dimmest red dwarfs, the slowest burning stars, will eventually flicker out. What remains are remnants, invisible husks of what once was. A universe of ghosts, cold black stars, dead planets, black holes spinning in silence, but still. Dark energy continues, space grows, distance deepens, and entropy.
Out the quiet unmaking of order spreads.
It is not a violent end. There is no great collapse, no shattering of form. It's only stillness. Even black holes, those devourers of matter and light, do not escape this fate. Through a process called Hawking radiation, they too slowly leak their energy back into space. One by one, they vanish, not in an explosion, but like a breath released across unimaginable time. Eventually, what remains is not stars or planets, but particles, thin, scattered, stretched across an ocean of nothing. No structure, no fire, no memory, just the heat death of the universe, a state where everything has reached the same temperature, too low to create motion, too even to spark change, a flat, quiet, infinite dusk. And yet, there's something hauntingly beautiful in that stillness, not an ending, but a resting, a completion of the long, slow story the cosmos began in its earliest breath. You are still there, floating, not in body, not in form, but in thought, imagining the rhythm of a universe that has exhaled everything it ever held. Some scientists propose other fates, a big rip, where dark energy grows stronger over time, eventually tearing galaxies, stars, atoms, even space itself apart, or a big crunch. If gravity ever reclaims its power, reversing the expansion, it's collapsing all back to a single point. But with what we know now, the future seems to lean toward cold, not violence, but fading, a whisper, not a scream. Still, as you rest in this thought, you might wonder if nothing remains. Does the story end? A hidden layer, a secret buried in the silence? Might this not be the end of the universe, but merely the end of one chapter? After all, the cosmos has surprised us before, and even in its quietest moments, there may still be echoes, clues of something waiting beneath the stillness. And so your journey drifts onward into the next chapter, echoes beyond the end. Silence is not the absence of sound. It is the presence of stillness. It's a space where something once was and maybe still is, in some quiet, invisible form. You drift now through a universe where stars have faded, where galaxies have vanished beyond reach, where black holes have sighed their last into darkness, but you are not alone. There is still something here, a shimmer of memory, a trace, a question that hangs in space like the echo of a note once sung. What happens to information, the shape of things, the records of events, the precise patterns that once defined particles, planets, people? Physics insists on a curious truth. Information cannot be destroyed, even when a star collapses into a black hole, or a notebook is burned, or a signal vanishes into static. The information is still there, encoded in some deeper fabric. It may be tangled, scattered, unrecognizable, but it isn't lost. And so we ask, if the universe ends in stillness, what becomes of its memory? Some physicists believe that black holes, even as they evaporate through Hawking radiation, somehow carry information away in their final whispers. Others think the surface of the universe, its boundary, its horizon, may encode a perfect record of everything within. It's called the holographic principle. The idea that our three-dimensional universe may be a kind of projection, it's like a shadow cast from a higher hidden plane, a strange thought, but not stranger than reality itself. And so, as the cosmos grows quiet, perhaps it is still writing, not in light or sound, but in the delicate curves of space-time itself. Perhaps the universe never forgets. It only stops speaking out loud. Even more curiously, some imagine that what we call the end might seed something new. That in the deepest silence, at the lowest energy states, fluctuations could rise again. Quantum foam, restless even in death, might give birth to new bubbles of space, new universes, each with their own laws, their own time, their own stories. This is the idea behind the multiverse, a vast sea of universes, where ours is but one crest on an infinite wave. Perhaps our Big Bang was the echo of a universe that came before, and perhaps someday, ours will whisper the next one into being. You rest within this thought that even endings may be beginnings, that even in darkness, there is a pulse. And maybe, just maybe, the universe is not a line with a final stop, but a cycle, a rhythm of expansion and rest, silence and spark, like the breath you take now, in and out, in and out. A pause is not a conclusion. It is the space in which something new can form. Still, this may never be confirmed. We may never witness the next breath. We may only ever wonder, and that too is enough to wonder, is to honor the silence. To ask is to carry the light. And so in this hushed universe, you listen one last time, not for answers, but for echoes. They come not in words, but in the gentle certainty that the cosmos continues, even when we cannot see how. You are part of it. Not separate from the stars, not distant from the dark. You are made of the same stillness, same pattern, same possibility. And now, as you float at the edge of thought, the edge of time, you feel something gentle stir. Not an end, but a door, not a silence, but the breath before another question. And with that, your journey continues. Into the final chapter, you, made of stars,